All right, welcome to second semester. Let's see if I can master recording in a different way, a little bit more technological way on the first chat. All right, wish me luck. Okay, so pause me and copy that down. I'm going to scroll so that you can copy everything first like usual. All right, and then go ahead and copy that down. Seems like I'm scrolling more than usual, but it's just because this page is a lot smaller than a normal page. This is a dotted line right here. Okay. All right, a little bit. Oh, no, that's it. I thought there was a little bit more, but there's not. Okay, so rectangular coordinates are what we've studied our whole math life. X comma Y. We can thank Rene Descartes for rectangular coordinates. Remind me on the Zoom call and I'll tell you a story about how he came up with the coordinate plane. So X comma Y, that's old news. This chapter is all about polar coordinates. So instead of X comma Y, we talk about R comma theta. So I made a little note there. We start with theta, and I'm going to show you exactly what that means right now in this example. So first, let's learn how to plot some points. The axes are not labeled X and Y anymore. The x-axis is now called the polar axis, and the origin is now called the pole. If you look at polar graph paper, or the polar graph paper that I posted, you'll see that it actually has a bunch of concentric circles. Hopefully you have that for these notes, okay? And you'll see why in just a second. So I am so in the habit of labeling the axes X and Y. It's like I literally, as I was drawing these graphs, I had to erase every single time because I put an X and a Y. So if I do that and I don't catch it, please let me know. When we're this whole chapter is about polar, so there's not going to be many, if any, instances where we actually do want an X or a Y. So here's what we do. We start with theta. Let me change my color really fast. Oh, there's some really cool colors on here. Okay, I'm going to stop being distracted. We start with theta, so we do a rotation. We go negative pi over 4, so hopefully you remember that that's a rotation starting at the positive x-axis and going clockwise. So negative pi over 4. And then on your polar graph paper, you're going to count out, because this is the R, the 2, yeah. You're going to count out 2 of those little circles that you have marked off on your graph paper. So it's probably going to be somewhere around here. And we're going to plot that point. And this point right here is actually the answer to the problem. So the rotation, we mark out negative pi over 4. That's where the line comes from. But the point is actually the answer. We're plotting a point just like we would in X comma Y, but these are R comma theta. So for a negative R value, first, we always start with theta. That's why I wrote it in red directly above. We're going to rotate a positive pi over 4. So you can see on your polar graph paper that those angles are marked off for you. Actually, you might have to label them now that I think about it. And then with negative, that means instead of going out 1, 2 circles in this direction, we're going to follow that line into the opposite quadrant, and we're going to count 1, 2 circles in that direction. So that point is the point negative 2 comma pi over 4. Okay, let's do one more. So 3 comma 0. So 0 looks like an XY, but it's not an XY, it's an R theta, okay? So we rotate 0, that means we're right here. And then we count out 1, 2, 3, and that ordered pair is R3 comma 0. And you're like, well, that's exactly the same as 3 comma 0 in the XY plane. And we'll talk about that as we get further into the chapter, okay? All right, so let's look at example 2. Plot the point and find another polar coordinate with a given characteristic. So let's first start by plotting the point. So I want you to plot 4 comma 3 pi over 4. Remember what we just did in example 1. We're going to start with theta, we're going to rotate, and then we're going to count out 4 circles on that line. All right, so hopefully you remember 3 pi over 4 is in the second quadrant. So we rotate 3 pi over 4. And then we count out 1, 2, 3, however you want to mark this. I mean, you guys have the polar paper. There's the 4th circle out. So you don't need to make those little dots that I made. I'm just trying to indicate that I'm counting out the 4th circle. Okay. Now, the second part of the problem, find another polar coordinate with a given characteristics. So they want me to find a polar coordinate now with a positive radius, but they want the angle now to be between negative 2 pi and 0. So the negative angle means I'm starting on the positive x-axis and rotating counterclockwise. So maybe something like that, huh? And that's the only way to get a negative angle between, that's the only way to get an angle between negative 2 pi and 0. Is to go from the positive x-axis. I can't do like a full circle and then some because then I'm not going to be in that interval. So I just need to figure out what that angle is. This would be negative pi over 4 in that quadrant and then negative 3 pi over 4. So this is going to be negative 5 pi over 4 is my theta. And the r is still the same. I counted out 4 circles. Okay, the r is still the same. Now this one wants a negative r value, but an angle between 0 and 2 pi. So I got to figure out how that's going to look. The negative r value indicates to me that my rotation is actually going to end here, and then I'm going to flip over. Remember what we did on this problem? We did our rotation on part B. We did our rotation, right? And then we flipped into the opposite quadrant. So over here, if I know, whoops, I passed it. If I know I want to land here, but my radius is negative, that means I started here and flipped to land there. So my angle should be positive between 0 and 2 pi. So I need to count this one from the positive x-axis and going clockwise. So I need to think that's in the 4th quadrant. So 1, 3, 5, 7. So this is 7 pi over 4. And then the negative radius, one sec. The negative radius means I counted out 1, 2, 3, 4, but I flipped it to over there. Okay, so negative 4 is my radius. All right, and then the last thing, we're going to be talking about converting from rectangular to polar or vice versa. So let's see, let me look at trying to be color consistent here. Okay, there we go. So we're going to use the top 2 formulas, the cosine theta equals x over r and sine theta equals y over r. We have those memorized. We're going to use those when we are given r and theta and we want to find x and y. And we're going to solve for x or y because we're trying to find x and or y, usually and. So I can rewrite this equation as x equals r cosine theta, just multiplying by r on both sides. And I can rewrite this equation as y equals r sine theta, again multiplying by r on both sides. So if I'm given an r and a theta and I need to find an x and a y, I'm going to use those 2 equations. Down here, I'm going to use obviously it's going to be the reverse, right? When I'm given an x and a y and I need to find the r and theta, And you can see here, I don't need to do anything to this. I can already solve for r. I mean, I'm going to take the square root, obviously, but and then for this one, for the tangent, which again, these are all formulas we already know. For the tangent, I want to be able to solve for theta. So I'm going to write that to find theta. Okay, so let me show you visually. We have, oh, that was my lights that just turned on. Okay, we know how to plot. We're saying that this is our ordered pair right here, the big fat dot that I have on my graph. So we measure out theta, or we rotate theta radians, and then we count out r and we land on the dot. That's what we just learned, right? Well, that's going to be equivalent to just counting out the x and the y. So over x and up y. We can figure out the relationship between the r and the theta and the x and the y using the formulas that we just discussed. Okay, so that's it. That's all for 9-1.